All right, so let's take a look at our chapter 6 topics. We actually have a little bit of review in 6.1. A lot of you noticed, hey, this idea of an absolute extremum, we actually already talked about in class because we started off contrasting absolute versus relative when we were introducing the relative extremum, relative max and mins in chapter 5. So the big thing on this one is the application problems that you're going to see in 6.1 are typically they give you the formula and then you find an appropriate window and find the maximum or minimum. Most all of the ones that you're going to see in 6.1, whether they're application or not, utilize Desmos. Desmos is definitely allowed on your test. So, and encouraged. Keep in mind as we're talking about the test, the setup is going to be the same as your chapter 5 test. Take home test, for this one, it's going to be open book, open notes, but no resources like live help, like a paid tutor or someone else helping you. I also set it to be a 3-hour window from the time you open it. I think that's what I did for the last one, which should be more than enough time. This test is actually, in my view, a little bit shorter. So you should block, I would say, 1 to 2 hours to take it for this. We'll go over more administrative stuff as we go through too. So let's take a look at 6.2. 6.2 is all about finding max and mins with application, but the contrast here in 6.2 is that you have to build the model. So helping to build the model is what those two Desmos activities, the Desmos optimization task 1 and optimization task 2, both of those start, well, the first one starts in 2 dimensions, the second one in 3 dimensions. And there's kind of a limited number of problems that I picked out of the 6.2. You'll see if you look in your textbook or watch the videos that are embedded in your ebook, they discuss a lot more types of models that you could optimize. What I really want you to focus on is the 2D examples. Most of these are rectangles. So for example, in the Desmos activity 1, you're looking at a picture frame. In some of the ones on your MyMathLab homework, you have like a rectangular pin and you put dividers in it. And so it's kind of a variation of that rectangle. And then the optimization task number 2 goes 3-dimensional with looking at the volume of a particular box that you're going to build. So really focus on those ones. If you understand the Desmos activities and the selected few that are in the homework, it's going to follow kind of this pattern. I'll pick a 2-dimensional optimization and a 3-dimensional optimization. So in this one, we really didn't even see any circles or cylinders for the most part here. Okay, hold on, guys. I think we have one person beeping in. Okay, let's see. I think Ben is joining us. Welcome, Ben. We were just going over, I don't know if audio is connected for you yet. We were just going over our PowerPoint. And Ben, I don't see anything on yours for information. If you have a question, you can type in the chat box. I don't see your audio on yet though. All right, so I'll keep going and I'll stop in a couple minutes because in terms of questions, with only 2 participants, you guys will direct what we do here in a minute. So let me go back here, got caught up with my clicks there. But from 6.2, we skipped over section 6.3. That was some specific business applications that we really don't have time for, but we did spend some time in 6.4. 6.4 is definitely, in my opinion, kind of the newest tough concepts because you have some technical skills with the implicit differentiation. You want to watch out for the ones where you have products. I'm not going to give you any quotients where you have to use quotient rule on the test, but you do have some products. So you want to make sure that you study the examples that we went over in the Zoom and also the examples that are in the Desmos activity for your implicit differentiation. The only 2 types of problems that you're going to see are problems where they say find dy dx using implicit differentiation and find the equation of a tangent line, where you have to take the dy dx you found, plug in to get the slope, and then plug in for a point. Now, when we pop over to Blackboard in just a minute, I'll show you guys the Desmos coding link that's right below the test that you guys can use on the test. hold on guys, I think, let's see, I think we have a checkbox. Oh, no quotient problems, yes. So I think in the homework you didn't have any on the implicit differentiation with quotient rules because they just get really, really long if you have those inside implicit differentiation. It's definitely not that you could never create a problem where you had to do it, just not what we're gonna look at. So let's go on to 6.5. 6.5 had more word problems in the form of related rates problems. However, all the related rates problems that we did together and that you see in your homework are of the geometric sort. You're going to have circles, spheres, cubes, and that's really it. So you need to make sure you're familiar with the formulas that you need for the area of a circle, the volume of a sphere, and the volume of a cube. I think you have practice of each of those types in the 6.5 homework. And again, those are the ones that I'm going to restrict it to on the test. For our last section with 6.6 differentials, there's two main tasks. You're going to work on finding a dy given an x and delta x, very similar to your homework setup. And you can also use your differentials to find maximum areas. And the particular types of problems that you should expect to see: circles, I think we had a square example in your homework on this one. So circles, squares, and areas for those, and cubes and spheres and volumes. So let me pause here for a second and ask about any questions you guys have right now.
The formulas from 6.5
Yes.
with the circles, spheres, and cubes. So is it just like a plug-in formula per
Yes.
se?
What I
Okay.
mean by that, and I'll go ahead and I'm going to exit out of, I exited out of something I didn't mean to. I'm not sure if it's still screen sharing for you guys.
It's just
Does it still show that PowerPoint?
yep.
Okay, good. Okay, so let me just type the formulas in. For the area of a circle, hopefully it'll let me do this pretty easily here. For the area of a circle, we're just talking pi r squared here. Okay, we're just going to type pi. We're going to be really fancy. So for some reason, I can't always navigate all my menus when I'm in Zoom. So pi r squared, and then think about for your sphere, the volume that you're going to need is 4/3 times pi times your r cubed. So in particular for the spheres, you have a Desmos blowing up a balloon activity in the 6.5 assignments. So I'll make sure we see those on Blackboard in a second. But that example on the Desmos activity walks you through using the 4/3 pi r cubed to do a related rates problem. So that's the reference there. And then I think in the Zoom that I did, we also did a cube. So just for a cube, we're thinking just volume equals, uh-oh, sorry, my chat's going crazy here. The volume equals, I'm gonna hit go. Just side cubed here. So nothing fancy going on with our formulas. But you may just want to have those handy with an example of each before you get started. Did that answer your question?
Yeah, I did. Thank you.
And welcome, Grant. So you just popped in. We were just taking a look at our list of topics. Then let's see, let's take a look at this one since we talked about formulas. So the same formulas would apply for this page. Area of a circle, volume of a cube, volume of a sphere, and then the area of a square, just side squared there. So the same exact formulas. Now, keep in mind on 6.1, that's where you're going to see me handing you the formula to take a look at graphing and optimizing. And then in terms of building models, let's actually go back here. The only ones you're really going to need formula-wise in 6.2, most of these are, so length times width. And then for your box, volume equals length, width times height. All right, so that should be all the formulas that you need there. Let me go ahead, and since we're talking about some of these Desmos activities, I'm going to stop the share, and I'm going to share another screen here. So I'm going to take us into Blackboard. All right, so if I take us into our Blackboard course, let's just go over the assignments in terms of the Desmos, the key Desmos ones you should definitely review. So I'll talk about the coding up here for a second in a moment, but the optimization tasks, these are the 6.2. So there's no Desmos for 6.1, but these two definitely review for the 6.2, the implicit differentiation, and then there are 3 for 6.4 and not any for 6.5. So the blowing up a balloon one, that was the one that I referenced just a minute ago with the volume. We did not do a volume in our Zoom, but what it does is it walks you through looking at this example and going through the volume formula. So definitely don't skip going over all of these Desmos before you get started, because a lot of the ones that are picked for the test really utilize the things that are in the Desmos. And also, if you don't understand part of the Desmos activities, I discussed some of them in Zoom, in the Zoom sessions, if you haven't watched those yet, but definitely reach out and let me know what questions you have as you go through those if you get stuck. So let's go back to the assignments page. I just dropped a quick link to your chapter 6 test in here. It's open right now, meaning if later this evening you feel like you're ready to take it, you can take it. Like we mentioned before, I think we had at least one person pop in since then. So I set the time for 3 hours, and it's open book, open notes, just like before, but not open other people. So no classmate help, no live resources. And then you can also use Desmos for the whole thing. And to help you guys out, this second link, the implicit differentiation for Desmos check, maybe I'll add right in here. This is for the chapter 6 test. Rather than having to go in, sorry guys, this blocks some of my buttons. It takes me a little longer. Rather than having to go in and go back through your activities, this is just another activity you join. And what it allows you to do is replace your formula, or replace the formula here. I think on the, when you guys enter it, it'll say replace this formula and put the equation that you're looking at, and go ahead and use this to test your implicit differentiation problems. So right now, if you haven't worked through the implicit differentiation for Desmos, sorry guys, wrong folder there. This is the Desmos implicit differentiation. It's just like that. I discussed that one heavily actually during one of those Zoom sessions. All right, so other questions or any specific problems we want to go over? All right, so what I will do is, I don't want to necessarily take up more of your time than is needed, but I will end our meeting here in a moment, so it'll boot you out. But then I will stay on Zoom for if you have some questions as you're kind of going over stuff in the next hour till 1 o'clock. That way, if anyone else pops in for the review session and this is it, um, you can pop on and ask some questions then. But um, keep in mind, I don't think I talked due date specifically. We do not have class next Tuesday. We have Easter break. So when you look at the due dates for this, everything is set to close. Let me look at my calendar and make sure I'm telling you the right date. It is set to close on the 15th. So we do have class on the 16th, that Thursday. CVCC has classes the 16th and 17th. But that'll give you guys a week to get in there anytime during that week. All right, so I see something in the chat box. Math test. So it will be due the end of the day on Wednesday, April 15th. And I need to double check to make sure I changed every single one of your My Math Labs, but the My Math Lab homework will also be due the end of the day, Wednesday, April 15th.
Okay, so we still have a while, but yeah, I'm probably gonna do a lot today, and then possibly maybe get on Zoom and talk to you about some problems if I do need it.
Yes, and what I will likely do on Thursday, I won't like have a scheduled Zoom session, but I'll be available for people who want to just pop on and ask some questions, just as a drop-in help session as well. So that's, Thursday is some extra time. And then also next week, I don't plan on having office hours necessarily Monday, Tuesday, or Wednesday, since those are break days and part of our spring break. But if anyone has questions, I'll still be checking email at least once or twice a day just to see if anything pops in, since I know you guys have that test open. And if you have some questions, I am available to set up individual Zoom sessions if needed. So know that that's an option, because I know for a lot of people, with everything going online, it's kind of a balancing act of what is first priority. So hopefully that week it gives you guys some breathing room to catch up and get that done. So any other questions for me?
When does class end? When does this semester end?
And so, so here's, we've been told a couple different things in terms of options, but my plan is to keep us on track to end by the normal time we would. So I think, make sure I'm looking at this right, I think May 7th was supposed to be our last day. And my plan is for us to finish up by then. So if there are extenuating circumstances, for those of you who are watching this later after it's already been recorded and posted on YouTube, if there's extenuating circumstances and something pops up, I do have some leeway where I can do some extensions, but it's kind of on a case-by-case basis as needed. My hope is that as long as everyone is kind of keeping up, hopefully we won't necessarily need to do that, but it's there. Meaning, if you find yourself falling behind as we finish up April and head into May, don't hesitate to reach out. But my plan is to go through our last unit. We're going to be covering some topics in Chapter 7, and we may have time to cover just one section in Chapter 8, just depends on our timing. And then one more test, which I anticipate being online. And then it looks like right now, our final exam will also be online. That's the most current information that I have. So I will be kind of looking at those dates and doing it so that we are finished up and I can submit grades that week of May 11th and 12th, as long as nothing pops up for anyone individually that poses a problem. So likely, again, depending on what's going on, we should be finishing up our last unit test that last week of April and May 1st. It's kind of a short last unit. And then reviewing and opening up our final, probably May 6th or 7th for you guys to take. And in terms of our class, we don't have any projects or anything kind of extra that I'm going to be springing on you guys at the end. It really is just finish up our last unit. We'll have my math lab, we'll have Desmos, we will do our unit test online, and then review for our final exam. The good news is a lot of the things that we covered at first with derivative rules, we kept on using. And then when we get into antiderivatives, we're going to get even more practice. Meaning if you've been doing well, chances are this last unit is just going to fall in line. Good question. Other questions?
Are there any formulas that I missed from like the first 20 minutes of class or the session?
Good question. I did go back and I didn't add these to, maybe I'll update our PowerPoint after this, but I didn't originally have these in for 6.2. These are formulas most likely that you use in your homework section. Just knowing area of a rectangle, length times width, area of a box, length times width times height that we use in those Desmos activities. In 6.4, there's no special formulas. And then in 6.5, with the related rates, we're going to restrict this to area for circles, volume for cubes, volume for spheres. And then I think in 6.5, you have one that's a square, like area of a square, so side squared. I'll clean those up a little bit when I post them. But there shouldn't be any other like cylinder or trapezoids or anything else that you should need to know there. Other questions? All right, well, thank you guys for participating. I will edit that PowerPoint, make those formulas look better and post it and get this video sent out. But after I close down our meeting, I will go ahead and in just a minute or two, start another one in case you want to pop back on. All right, so feel free to send me emails. If I don't hear from you before the break, enjoy your break. And I will be sending you guys just reminders, or if there's any changes, I will let everybody know. All right, have a good rest of your day.
All right, bye-bye. Bye, guys.
Bye-bye.